This is video 1 for chapter 20, and chapter 20 is all about electrochemistry. Electrochemistry is obviously a relationship between the electricity in a chemical reaction. So how do electrons get transferred? And in this chapter, you're going to hear the words oxidation and reduction quite a bit. And so we're going to talk about what those two words mean. So by the end of the video, you should be pretty comfortable with what the definition for oxidation is, what the definition for reduction is, and then also what an oxidation state is. Now, you actually have learned oxidation states before. It's not a phrase that maybe all of you are comfortable with, but an oxidation state is just what you guys have thought of as the charge on an ion. So for example, we know that sodium, when it becomes an ion, because it lives in group 1, has a +1 charge, whereas oxygen, because it lives in group 6, has a -2 charge. And these charges are what we refer to as being their oxidation states. So you already know oxidation states for most elements, and you know that the oxidation states for transition metals change. So I don't want you to be tripped up by that terminology. It's just kind of another word for charge. Now, what is an oxidation reduction reaction? Well, sometimes we'll just shorten this up and call it redox. And it's a chemical reaction where the oxidation state of one or more substances in the reaction will just change. Now, the process oxidation has to occur at the same time as reduction occurs. And what the words mean, okay, this is important for you to know. Oxidation is losing electrons. So when there are electron loss, that is an oxidation. And generally what will happen to the oxidation state or the charge is that it will go up. So for example, you might be at a 0 charge and go to a +2 because you've lost 2 electrons. You might be at a +2 charge and go to a +4. It also could be negative. You could be at a -2 and go to 0. So as long as your oxidation state or number, the charge on you, increases, you've lost electrons and you were oxidized. Reduction is the gaining of electrons. And so your oxidation state is going to have to go down because when you gain electrons and electrons are negative, your charge will go down. So your charge might be going from a -2 down to a -4, or from a +2 down to 0. Okay. Now, there's a couple ways you can help yourself remember this, and there's 2 different phrases that I've used over the years to help kids remember. But one is oil for oxidation, and then for the other part, oil rig. And I'll explain what that means. So for oil, it's oxidation is losing. And the rig is reduction is gaining. So if you can remember oil rig, oxidation is losing, reduction is gaining, oil rig. That's one way. Another way is that, and I know they use this in biology quite a bit, is that Leo says Ger. So another way of remembering it is Leo. And what you could say here is losing electrons is oxidation. My smartboard's not working very well, so you'll have to forgive all these goofy lines that are showing up. Leo, L-E-O, losing electrons, oxidation. And then Leo, the lion, says Ger, G-E-R. And that stands for gaining electrons is reduction. So, however it works for you is really up to you. Just try to remember oxidation is losing, reduction is gaining. And one of the things you have to realize is that a substance can't lose electrons unless something around can take them. And nothing can grab electrons from something else unless something's there willing to lose them. Okay? So we're going to look at a specific example that you have in your notes. And I'm going to erase just this writing above it so it's clearer. So if you look at this reaction that you have in your note packet, what it says here is that you have a zinc solid reacting with hydrochloric acid, and that's making zinc chloride and hydrogen gas. Now last year, you would have classified this correctly as a single replacement reaction, and that is still correct. It is a single replacement reaction, but it also falls under the category of oxidation and reduction, and here's why. All elements in their elemental state are assigned an oxidation state of 0. You guys actually learned this back in chapter 4. So if you're having trouble with oxidation states, don't forget that you could go back to chapter 4 and look up how you'd assign those. Now, since zinc occurs naturally as a solid metal, we would assign it an oxidation state of 0. Now we look at each of these compounds. Hydrogen's in a compound, and since it's written first and it lives in group 1, we would assign hydrogen an oxidation state of +1. And we would assign chlorine an oxidation state of -1. We look at the next set, the products. In this compound, zinc is a +2 charge, and chlorine still has its -1 charge. And then we look at hydrogen, and it, because it's hydrogen gas, diatomic molecule, this is its elemental state, it is assigned an oxidation state of 0. So if we look at the 3 elements involved in this reaction, the zinc had an oxidation state change. The zinc went from 0 to a +2. Its oxidation number increased. Therefore, the zinc is oxidized because it lost electrons. The chlorine did not change its oxidation state at all, so the chlorine was neither oxidized nor it was reduced. If we look at the the H, hydrogen went from a +1 charge down to a 0. Its charge went down, so it was reduced. So the way to identify what was oxidized and what's reduced is by looking at individual oxidation states, or charges, as you guys are used to calling them. Now, since these things have to happen together, the element zinc was oxidized, but it can't lose electrons unless hydrogen is there to take them. And hydrogen cannot take electrons from zinc unless zinc is willing to give them away. So, even though the zinc is oxidized, it causes something else to be reduced. So we call it the reducing agent. And even though the hydrogen was the substance to be reduced, we call that one the oxidizing agent. And just remember, agent is kind of like the reason something happens. So zinc can lose electrons because it's forcing something to take them, and hydrogen can take electrons because something is giving it to them. So the item that is always oxidized is also known as the reducing agent, and the item that is reduced is also known as the oxidizing agent. Now, you learned 5 types of reactions last year. You learned about synthesis reactions, okay? If I were to do a simple example of a synthesis reaction, elements in their elemental state are assigned a 0 charge. So both sodium, solid, and chlorine gas would be assigned a state of 0. The sodium, though, in the compound becomes +1 and the chlorine becomes -1. So not only was this a synthesis reaction, but it also is now, hopefully you recognize it as a redox reaction. Decomposition would be exactly the opposite. So the charges start out different and they finish differently, but decomposition is also always redox. I just showed you a single displacement. Single displacement is also always redox, and so is combustion. The only type of reaction that you learned about last year that is never going to be oxidation reduction is a double replacement reaction. So this is your introduction to redox equations, and hopefully you understand the terms oxidized and reduced, oxidizing agent and reducing agent, and how to find the oxidation states. Again, that material for finding charges is covered in chapter 4.